Hey everyone, my name is Brendan, and today I'll be walking you through section 5.1, Distance and Accumulated Change. So this section is used to find area under a curve, to determine minimum possible change, to determine maximum possible change, and to determine average total change across an interval. The key components to remember are that distance equals time times velocity, what it looks like in a table versus what it looks like in a graphical representation, which I'll do some examples in just a second. That n is the number of points on your interval. Usually a higher n means that you'll have higher accuracy within your data. Change in t is the change in the distance in between your time intervals. That's given with your graph or your table. Once again, the more data you have, the more accurate your approximation is going to be. Now, in order to find that approximation, which is the average change on the interval, you take your first result plus your second result, and then that whole total is divided by 2. Now let's look at an example I got from Wiley plus Orion, which is sort of a workbook that we all have access to. In a table, here's the information. A new grocery store opens and the owner would like to assess the success of the store. The owner does this by calculating at the end of each month the average number of customers per week in that month. Using the owner's table of data from below, assuming that the number of customers is increasing, what can we say about the total number of customers for the new store in the first 16 weeks after opening? So this is a great first example because it's pretty clean numbers and it'll be pretty easy to point out a few key things to you guys. So our t interval is always our time. So t time, which is in weeks here, and then customers per week, which is just number of people. So we have time and then the data itself. So the way you figure out what the change in t is by taking 4 minus 0, so largest minus smallest. 4 minus 0 is 4. 8 minus 4 is 4. 12 minus 8 is 4. 16 minus 12 is 4. So we know that change in t is equal to 4 throughout the entirety of this graph. And the customers per week, we have 0, 1,800, 3,000, 4,000, and 4,500. Now for a graphical representation. The population growth of a small city measured in thousands of people per year, settled by 2,000 people, is denoted as P of t and given by the graph below. Choose the best estimate of the total population of this city after 100 years. So we know through the given graph and through the wordage here that we only have to go to this 100 number. So although the graph continues, our cutoff's at 100 because it's saying what is the best estimate of population after 100 years. So we start at 2 because, once again, this is population growth in thousands of people per year. So we start at 2 because 2,000 people settle the city. Once again, let's look at the bottom here to get our time, our t interval, change in t, take the bigger minus the smaller. 20 minus 0, 20. 40 minus 20, 20. 60 minus 40, it's 20. 80 minus 60 is 20, and 100 minus 80 is 20. Then you can sort of see along the line here, you're going to graph as you go, but I'll get into an example of that in just 1 second. You might be asking yourself, so what? What do I do with all of this information as we lead up to either the final or maybe even the real world? Here's an example. So using the same data as I got earlier from Wiley plus Orion, we're going to take at the least how many customers has this store had in its first 16 weeks. So it's asking us at the least. So that means that our n, which is equal to the total number of data points minus 1, is going to be 4. You might also remember that the change in t for this example is 4 as well. So because it's asking for the least, we're going to cut off this week 16 number of 4,500. So we're going to take 0 times 4, 1,800 times 4, 3,000 times 4, and 4,000 times 4. As you can see here, you add those together, so you get 0 plus 7,200 plus 12,000 plus 16,000 equals 35,200. And then you can write it out. At the least, this company has had 35,200 customers in its first 16 weeks. So once again, when you're asked to find the least amount or a lower estimate, make sure you drop off the highest number and include the lowest number. Example number 1 continued. Now we're asked at the most how many customers has this store had. So this is asking for an upper estimate of the data. So that means we're going to drop the lowest possible data point. So we're going to take the totals for week 4, week 8, week 12, and week 16. And because the change in t, which you might see as triangle t sometimes, is always 4, and that doesn't change even though we're dropping this and adding this, you're going to multiply it by 4. 1,800 times 4, 3,000 times 4, 4,000 times 4, and 4,500 times 4. So we have 7,200 plus 12,000 plus 16,000 plus 18,000. That equals 53,200. So we know at the most this company has had 53,200 customers in its first 16 weeks. Now some analysis of this. Through our work that we did in the last 2 slides, we know that probably between 35,200 and 53,200 customers have come within the first 16 weeks of this company's existence. So to get an average for this, which is going to be an approximation because we haven't learned how to find the exact amount yet, we're going to take our 2 totals, so our 35,200 and our 53,200, divide that by 2. So when we add the 2, we get 88,400. You divide that total by 2, and you can say that there were approximately 44,200 total customers in the first 16 weeks, and that's a pretty good estimate. Example number 2. So I decided to make my own graph for this just because it's much easier to view than the other graph that I used when I introduced the concept of the graph. So it's asking us, at the least, how far has the car traveled in 4 seconds? So that's asking for a lower estimate of the data. So as you're looking at this, you might be able to tell that, okay, we're given a 4-second estimate. How do we figure out what the least possible distance the car could have traveled is? So we're going to drop off this 4, it looks like about 50, and we're going to replace it with this 0, 0. So the interval or change in t is found once again by taking higher minus lower. 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1, and 4 minus 3 is 1. So we take 0 times 1. This is 5 times 1, 20 times 1, and 35 times 1. So those are just your totals because something times 1 is just itself. So you're going to have 5 plus 20 plus 35, which equals 60. That tells us at the least the car has traveled 60 feet in its first 4 seconds. Now, example 2 continued. Once again, we're going to try and find at the most how far the car has traveled in its first 4 seconds. So that means we're going to add this 4 and looks like 50, and we're going to drop this 0, 0. So once again, the change in t has not changed. 4 minus 3 is 1, 3 minus 2 is 1, 2 minus 1 is 1. So 5 times 1 plus 20 times 1 plus 35 times 1 plus 50 times 1. So that equals 5 plus 20 plus 35 plus 50. That equals 90. So at the most, this car has traveled 90 feet in its first 4 seconds. Throughout our work, we know that the car has traveled somewhere between 60 and 90 feet in its first 4 seconds, and we can plug this into our average equation. Now, when you do that, you get 150 divided by 2 as your approximation, and that's 75 feet in the first 4 seconds. Now, I just want to review really quickly. If you're asked to find the greatest possible number, use an upper estimate. However, remember, when you're using a graph, sometimes if it's negative data, the upper estimate will be to the left of your line. If you're asked to find the lowest possible number, use the lower estimate. Once again, if you're looking at a graph and the data is negative on slope, the lower estimate's actually going to be to the right of that line. Now, this is summed up in this bullet point, which is never assume the upper estimate's a right-hand sum and the lower estimate is a left-hand sum. So always try and visualize what they're asking of you and figure out just what the data means. Now, if you're asked to find the average change in a given data point, use this equation. Lower estimate plus upper estimate divided by 2. Thanks for listening. I hope you guys enjoyed it, and I look forward to seeing what you guys have for me to check out.